Welcome to Learn IT Courses Online, and welcome to our Introduction to Database Administration. Why database administration? And this course, again, is geared to someone that might be new to IT altogether and is considering a career in IT, debating whether they should get into programming or something data-related or database-related or security, and you're kind of interested and curious about that. Or you might already be within IT, or you already have worked a little bit with database, but you'd like to specialize and get some information in a specific area. So why the database? Again, businesses or corporations and companies, governments or private sector could differ in terms of what they do. So it could be a retail industry, it could be food, it could be automotive, it could be any kind of company or corporation that it is. The technology that they use could differ. So for example, on an OS level, they might use Windows or Linux or Unix. On the front end, it could be a Java, it could be a .NET, a VB.NET, a C# application, ASPX.NET. But the one thing that stays central, that doesn't change, that is most important to the core of any company that we have, is the data. Data is central to all of them, and that is why there's a list of careers that are centered around the database. They kind of spiral out of that. And what am I referring to? You probably heard some of those terms, or if you look for a job, if you go to a website such as Dice or Indeed or Monster.com or any of the other ones, or LinkedIn, you'd find something such as database administrator or administration, DBA. You'd find data analyst. You'd find reports writer or business intelligence. You'd find ETL specialist. Sometimes they're worded differently, so it could be an ETL developer, it could be a reports developer, it could be a SQL developer. Terminology might differ, but at the core of all of that, the steps are very straightforward. And here at Learn IT Courses Online, it's as simple as 1, 2, 3. And we would like to get you to be aware of and ready to be a database administrator, a data analyst, a reports writer, business intelligence, or ETL developer. At the core of everything and the center of everything, they're all kind of cubes, but there's one central point. There's one core point where everything starts at, and that is our data. The data for any business is the most important step. It's where it all starts from. It could be a bank, it could be a restaurant and customers, it could be employees, an HR database. Regardless of the corporation, the category, the sector of that business, data is at the core of everything. So any of those careers that we mentioned, and we're going to start with database administration specifically, we start first and foremost with SQL, which is short for Structured Query Language. Theoretically speaking, that is the only language that relational databases speak. Again, there's other things, and that's why we hear not only SQL or pronunciated NoSQL, but at the core of it, basically SQL is the one language spoken by all relational databases. It's the core of all of them. It's how you get your data into the database. It's how you get your data out of the database. It's how you design your database. It's how you create your tables and store procedures and all the objects and how you modify them and how you get rid of them by dropping them. So at the core of speaking to the database, I need to know SQL. Then comes the next building block, and that is database design. A relational database is designed slightly differently. So it's not just like a spreadsheet where I go into something like an Excel and I will type in column headers and put my information, but I need to design it certain ways, especially if it's an OLTP and then you use what's called the rules of normalization and relationships and primary keys and foreign keys. And maybe it's a data warehouse where you have a lot of historical data and you need to aggregate it and you need to use what's called the schema designs and star schemas and snowflake schemas. And you get into a lot more complex, but at the core of it is being able to design my database in a way that it's easy to get the data in there and also easy to get it out and have a relationship between all the different and related elements within my database. After that comes security. Security, there's different layers and levels of security, but the most basic one is the user and then the privilege or the role that that user has. At a bank, for example, I might have a bank teller and I might have an HR person. The bank teller's responsibility is to see, or the information they're allowed to see is the balance and the bank account information in terms of how much I, as a customer at the bank, deposited and how much I withdrew, and that's the information that that clerk is supposed to see. However, they're not privy to see what an HR person sees, and that's how much their coworkers make an hour or salary-wise. HR, on the other hand, is the reverse. They get to see how much all the employees make on an hourly basis or a monthly basis or a salaried basis, but they're not allowed to see how much money I deposited as a customer to that bank. So that's where security comes in, where you create your users and give them different privileges, along with a lot more layers. But at the core of it, that's a simplistic point of view on security, on database. Then comes performance. As we keep adding more and more information to the database, again, when we just have a few hundred or thousand, or even hundreds of thousands of records, usually relational databases such as Oracle and SQL are outstanding. You get your data out very quickly. But then the deeper we get, now that we're creating millions of records and relationships between them, and we'd like to query them, and we have a lot of processes that are running on that database at the same time, multiple reports and different people entering information, performance becomes an issue. A report that runs in 3 or 4 seconds now might start taking 2 or 3 or 4 or 5 minutes. What used to take a few minutes, or things such as monthly reports, might now start taking hours. That is where performance tuning becomes very important. That's where I need to deal with, how do I make the SQL run faster? How do I allow my database server to run faster? Next comes what's called high availability. High availability means, suppose I have everything in one server, and that server crashes. Suppose I have everything in one machine, and that machine, for one reason or the other, loses a drive or it just crashes. Do I lose all of my data for my business? That's where high availability comes in. And there's different ways of applying that. The basic is to make sure that I have a backup and regular backups of my databases. And there's what we call backup strategies, where I would need something such as a full backup followed up by incremental backups. But then larger corporations can afford spending a little bit more with their systems to make it more readily available. And that's where we have things such as clusters, and in the case of Oracle, things such as data guard and high availability in the terms of SQL Server and clustering. So this is where we make sure that that data is available in case we lose it. It's available on a different server, it's available on a different drive, and it's very quick to restore, or is ready available in a standby database, or it could be another live node of our database. Then comes capacity planning. Capacity planning is where, whether I'm in Linux or Unix and I have a path, or I'm in Windows and I have something in a C drive, everything supposedly is in one drive, a C drive, and I only have 100 gigs and I'm at 80 gigs. I need to know, as a database administrator, at what point am I going to max out? Because I can't wait until we actually max out. And especially when we're dealing with hundreds of gigs and terabytes of data and nightly backups and different installations and other applications running on a database server, we need to do what's called capacity planning. We need to see how much, for instance, data that we're adding each month. So if we're growing at 100 gigs a month for the last year, then I need to have projections for next year and say, well, at 100 gigs multiplied by 12, we're expected to grow a minimum of 1.2 terabytes for the next year. And of course, I also need to check with my manager and with the business to make sure if there's any expected additional growth. So I can tell them before we run out of space that for next year, I might need 1.5 terabytes, for instance. So that's called capacity planning, is always watching out for my storage so I don't run out of space. Next thing is configuration. You install your database, you run your processes, you have a lot of reports running, and one of two things happen. You either have a very powerful machine and the database is slow, so you want to be able to change your configuration to use more resources, more memory and more processors and CPU power, or you're overusing the limit that you have and you need to lower down your use of processors or CPU or memory. That's where configuration comes in. Next comes install and update. And again, if you're dealing with a lot of the GUI interfaces that we have for most relational databases with SQL Server or Oracle, it's very straightforward. You just click next, 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 and pretty much you're done. Maybe a couple of usernames and passwords that you need to set. However, in a workplace, it's very different, because if I'm upgrading a database, at the end of that upgrade, I might need to restart a server. So if we have a business that's up 8 a.m. to 5 p.m., I can't just upgrade during work hours, but I need to coordinate with business and management to make sure that it's done within a certain window. And I need to benchmark it, running and test, and say, well, I need 20 minutes or 30 minutes for this upgrade or for this install, for this or patch or fix And those are the kind of things that we're going to talk about once we get into install and update. It's not just installing and updating, but seeing how it works in the workplace. Next is troubleshooting, not to be confused with performance. Performance is where I have a SQL statement, I have a report that used to run in a minute and now runs in 5 minutes. So it's just running slower, and I'd like for it to run faster. But troubleshooting is when I have an error message, is when something breaks, is when the computer crashes, the database crashes. Now I'd like to know, why did it crash? I want to look into log files, I want to look into my error logs and be able to see what the warnings are and what the error messages are, and how to go in and troubleshoot and fix that issue. Now comes another piece, and that is the data that we acquire doesn't always come from a front-end screen. A lot of the processes that we have could be files that come in from external data sources. For instance, this could be a central database for my restaurant, but I have branches in Nashville and Chicago and Detroit and Ontario and Beverly Hills. So my manager, Garth Brooks in Nashville, prepares an Excel sheet that I use my ETL processes, which is short for extraction, transformation, and loading, where I can connect to the Nashville branch, pick up that Excel sheet that my manager left, and drop it off into my database. So extraction means to pick up the Excel sheet from that drive in Nashville or that server. Transformation means sometimes I load it directly, but sometimes I need to change my data a little bit. So for instance, if I have a first name column and a last name column, but in my database I only have one, which is customer's name column, I would need to merge those two columns. I need to transfer them. And then load means I need to load it into my destination, my database. So this is the ETL process, and a lot of companies would need to use ETL processes because they're loading data from different sources. Also, that source could be a database. For example, we might have an OLTP database where we're transacting with or have online transactions with our customers. But then we have a data warehouse where every night we need to move that data to historical databases and aggregate that information. Would use ETL there as well. Last but not least, and this is something that is very important for the business, is reports. The reason the business has all this data is to be able to report on it. Why do we call it reporting, or why do we call it business intelligence? Is because we're not just looking simply on the numbers. We're not looking at what we sold yesterday, full stop. We're not looking at how much money we made yesterday, full stop. But with business intelligence, we're looking at reports that are going to show us trends and are going to show us future achievements. So we can see what store is selling more and what products are we selling more. So maybe we want to increase that, and which employee and what branch is selling the least, so maybe we need to retrain them or do something different. So this is where business intelligence comes in. Reports that would show us trends and would show us future growth and what areas we need to focus on, so we can drill down through charts and graphs and numbers and aggregations to have better projections of our future business and how we can grow through that. Now, normally, I wish I could say that certain areas are database administration, certain areas are reports writers, and certain areas are ETL development. However, from business to business, from company to company, the lines kind of, it's not a clear-cut line. So for example, in some companies, you would have a database administrator that does SQL, DB design, security performance, and a little bit of ETL. There's other companies where the ETL developer does ETL and uses an ETL product. But in addition to that, they're also involved highly in SQL development and performance, because that's something that it's important. And then on reports, again, integral to that is SQL. So they're very good in the reports application, development, GUI interfaces. They're good in their SQL, but they also might be involved in security and performance, because they need to create users for the people that access the reports and so on and so forth. And they need to have troubleshooting skills, because some of the reports are web enabled and some of them are use email notification and they error out for one reason and the other. So you need to be able to go in and troubleshoot some of that information. So the lines depend on the company that you're working with, but at the end of the course, if you were to study each of these pieces of the puzzle, we would be ready to be great database administrators, data analysts, report writers, business intelligence, ETL specialists, or terminology might differ a little bit, ETL developers or report developers or SQL developers. But at the end of the day, all of this will be covered once we cover those areas. I wish you the best and enjoy your course.